Hello everyone, can you all see me and hear me? Am I visible to everybody? I guess yes. Okay. So, hi guys, hello to your relations and functions lecture number 2. How are you guys doing by the way? And I hope that you are super duper excited for your lecture number 2. Right? Yes or no? Yes or no? Yes or no? Hi guys. So, we have already done and completed our lecture number 1 where we learned about introduction of sets, representation of sets and the different types of sets, right? If you have not yet seen the lecture, go right now and watch it first and then we will move on with our new topics. That is, today we are basically going to learn how do we represent sets diagrammatically so that operation on set becomes easier, and we will also learn about how to do those operations. Okay, so first of all we'll learn about Venn diagram, then we will learn about different operations on sets, intersection of set, complement of set, union of set, DeMorgan law and all of that. All right, and then this chapter will be completed. Okay, so we will be starting today's topic with Venn diagram. Hope you guys are super duper ready and excited for your today's lecture. Okay, so show me some Josh in the chat box. Come on. Ready everyone for today's lecture? Awesome. Okay, so first of all, we are going to learn about Venn diagrams that are used to represent sets and their operations. Okay, so what are Venn diagrams? Any idea? Well, basically, Venn diagrams are some diagrams that we make which are in the shape of rectangular boxes. Inside the rectangular boxes, we draw circles. These circles represent set. What they represent? They represent, for example, set A. This is representing, for example, set B. Okay. Now, if a circle is inside another circle, this represents, suppose, set C, which is a subset of set B, right? So, Venn diagrams, basically the elements are the sets which are represented inside the circle. So, everybody understood what is a Venn diagram, how we use it and why we use it? Okay, now the main operation or the main formula that is used to solve any type of Venn diagram problem is, if you have two sets, then the two sets can be represented like this, a rectangle containing two circles x and y. Now, if you want to know the union of two sets, now what do we understand by union? Union basically means the combination of two sets all together. So, it is always equal to number of elements in set A, number of elements in set Y minus n number of elements in x intersection Y. Now, why do we subtract x intersection Y? Because once you are counting the elements of set X and set Y, okay, this area is basically X intersection Y and it is generally counted twice. But we don't want to count them twice, so what we do, we basically exclude it once. Okay. Okay, give me 1 second. Yeah. So this is the basic operation that we apply on two sets inside our Venn diagram. Now suppose we have three sets. How will the Venn diagram look like? So it will be again a rectangular box, and this rectangular box will have the three sets A, B and C. Now this blue area is representing A intersection C. So this is common between A and C. This is representing B intersection C. So common between B and C. So like this we will have our formula. The union of A, B and C will be n number of elements in A plus number of elements in B plus number of elements in C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. Okay, so this is how the Venn diagram of 3 sets look like. Okay, now there are some important symbols that you need to know before we jump on to basically understanding what is union of two sets, how do we find union of two sets when the elements are given. So first of all, what is the symbol that we use for them? So union of two sets is represented by an upward U symbol. Okay. Intersection is represented by a downward U symbol. Complement is represented by set to the power of C or set name dash, like that. Now what is complement, what is intersection, we will learn, don't worry. Now let's learn about the different operations you can perform on Venn diagrams. Alright, first of all, starting with union of two sets. Suppose we have a set A and a set B. The union of set is defined as every element that either belongs to set A or belongs to set B. It is not compulsory that they should belong to both of them. It is saying either this or this. So what is important is or word here. Okay. So either the element is belonging to set A or the element is belonging to set B, it's absolutely fine. A union B will be combination of both. Okay. So the element A union B is required to belong to at least one of the sets of A and B. Alright. Now, here are some laws related to A union B, that is basically union of two sets. Law number 1. A union B is always equal to B union A. Associative law also holds true. A union B union C is equal to A union B union C. Law of identity elements. Union of a set with null set, that is phi, nothing, will be what? Obviously the set itself, because null set contains nothing. So even if you combine it, you will get the same set itself. Idempotent law. Union of two set A and A will be A only again, because if you combine set A with set A itself, you will get set A only. You will not get A square. Okay. And universal set law says that union of a set with universal set is universal set. Why? Because if you combine A set with everything, then the result will be everything only, na? Like complete combination of everything. So that's why union of the set. Okay, let's do one example here. If set A is 2, 4, 6, 8 and set B is 6, 8, 10, 12, then A union B will be what? So it's very simple. A union B is basically combination of both the sets. Okay. By combination we mean it should contain element of either this set or this set. So how can we find that? Can you tell me? What will be A union B? What will be A union B? What will be A union B? Who can tell me? So what did I say? A union B is basically either it should contain element of A or B or both. It's fine. So let's first write down the elements of A. 2, 4, 6, 8. Then in B we have 6 and 8. They are same already here. So we will not write them again. We will simply write the other two elements, 10, 12. So this is basically A union B. So here please remember 6, 8 are written only once. They are counted, they are written only once. Okay. Now let's learn about intersection of two sets. By intersection we mean elements that belong to set A and set B. That basically means it should be present in both of them. Or you can simply say elements common in both sets. Elements common in both sets. Okay. So an element which belong to set A as well as set B will be there in A intersection B. Clear to everybody? Understood, guys? Now, let's look at the laws of commutativity, intersection of two sets. So first of all, commutative law says that A intersection B is always equal to B intersection A. They are same. Associative law says that A intersection B intersection C is equal to A intersection B intersection C. Okay. So it does not matter that you change the order or the brackets, the answer will be same. Again, here we have something different. What will be common between set A and nothing? What is common between them? Obviously, nothing is common between them. So, phi and set A will have phi, that is null set, as common. Similarly, what is common between universal set and set A? Suppose this is universal set. Inside this we have set A. What is common between them? Obviously, set A itself is common between them because set A is inside universal set, right? Next, idempotent law says that intersection of A with A will be A. What is common between A and A? A itself, right? And lastly, we have distributive law. This symbol is called as phi. It is basically used to denote null set. Okay, Kevin? Lastly, we have distributive law. Distributive law says that intersection can be distributed over union. A intersection B union C will be A intersection B union A intersection C. Similarly, union can be distributed over intersection A union B intersection A union C. All right. So this is basically distributive law. Now, if you want to understand the distributive law through Venn diagram, we can also do that. So, first of all, if you want to know what is common between A intersection B union C, this should be union, right? Yeah. So, what is A intersection B union C? Suppose I have three sets A, B and C. Okay. Now, what is B union C? B union C is basically this whole part, right? Then B union C combined with what is common between B union C and A. So, if you want common between B union C and A, you will have this part. Let me use a different color for that. This is common between A also and B and C also. Okay. Now, similarly, once again, similarly, if we look at the diagram of A intersection B, let me take a bigger triangle. This is set A, this is set B, this is set C. What is common between A and B? This part. Next, what is common between A and C? This part. Now, what is union of both of them? Like combining both of them, what do you get? You get this part, this heart-shaped part. This part, right? Similarly, here also you have this part. So, don't they look like same? Yes, they are looking same. So, hence we prove that distributive law is true. Okay. Now, let's do one example. If set A is 2, 4, 6, 8, set B is 6, 8, 10, 12, find A intersection B. Now, A intersection B is basically common elements. So, what is common between A and B? Tell me quickly. Can you tell me what is common between set A and set B? Quickly. Can anyone tell me what is common between set A and set B? Well, if you look at the elements 6, 6, 8, 8. Anything else common between them? No. So, A intersection B will have 6 and 8. Simple. Right? Okay. Come on, let's do another quick check question. Let A be the set of odd numbers, B be the set of even numbers. Then what will be A intersection B? Can you guess? Set A is having all the even numbers 2, 4, 6, 8, 10, dot, 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 dot. Set B is having all the, set A is having all the even odd numbers and set B is having all the even numbers. All the odd numbers, suppose 1, 3, 5, 7, 9, 11 and so on. So, what will be common between them? What is common between even numbers and odd numbers? Very good, TTT. The right answer is empty. Nothing common, right? Between odd numbers and even numbers, nothing is common. There is no number that is even as well as odd, right? So, that's the answer. Okay. Next operation that we are going to perform on two sets is basically difference of two sets. What do we understand by A minus B? Well, basically A minus B is any element that is present in A which is not at all there in B. How we will write? Element present in A but not at all in set B. That will be difference of set A with B. For example, if set A is this, set B is this, find A minus B. So, what will be A minus B? A minus B is basically A minus B is all the elements of set A. 1, 2, 3, 4, 5, 6. But these elements should not be there in B. 2 cannot be there. 4 cannot be there. 6 cannot be there. Therefore, A minus B is 1, 3, 5 only. So, any element that is there in set A but not there in set B. Only those elements are there in A minus B. Okay. Very good. Next question is complement of a set. Now, what do we understand by complement? Now, if there is a universal set which has set A inside it. So, complement of set A is basically all the elements which are not there in set A. Okay. So, any element which is not there in set A, which is outside set A, will be complement of set A. Understood? Okay, awesome. Let's do a question. If universal set is this, set A is this, set B is this, set C is this, find A complement. A complement is universal set minus set A. Everything which is not there in set A. So, universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus what is there in set A? 1, 2, 3, 4. So, when you subtract them, you get 1 not there, 2 not there, 3 not there, 4 should not be there. So, we have 5, 6, 7, 8, 9. Very good. You guys are answering it absolutely correctly. Okay, now let's learn about union of sets and intersection of sets in a little detail with the help of Venn diagram also. Now, we all know what is union of two sets. What is it? What is it? So, union of two sets is basically everything that is there in either set A or everything that is there in either set B. Fine. Now, if I say find out A union B complement, that means find out elements which are not there in A union B. So, which elements? It will be basically universal set minus A union B. Now, A union B has everything A and B has. So, this will be basically, this shaded figure is basically A union B complement. Okay. I have already taught about Venn diagram at the beginning, beta. You were not there at that time. Now, suppose we have a universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A is this, set B is this, set C is this. Find A union C complement. So, A, let me change the color of the pen. A union C complement will be universal set minus A union C, right? It will be basically anything in the universal set which is not there in A union C. So, universal set is basically 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to subtract A union C. Now, what is A union C? This is A, this is C. So, A union C will be 1, 2, 3, 4, 5, 6. Because 1, 2, 3, 4 from here, 5, 6 from here. Now, you subtract it. 1 should not be there. 2, 3, 4, 5, 6. That's it. 7 should be there. Okay. So, finally, we have 7, 8, 9. So, what should be there in A union C complement? 7, 8, 9 should be there, right? Similarly, what will be complement of A intersection B? Now, A intersection B is basically whatever is common in A and B. Complement will be whatever is not common in A and B, right? So, whatever is not common in A and B will be A intersection B complement. Let's take an example. Find A intersection B complement. A intersection B complement will be again universal set minus A intersection B. So, we have universal set 1, 2, 3, 4, 5, 6, 7, 8, 9 minus what is common in A and B? Let's find out. 2 is common, 4 is common. That's it. So, 2 and 4 common. 2 subtracted, 4 subtracted. So, we get 1, 3, 5, 6, 7, 8, 9. Only 2 and 4 are removed. The remaining elements will be part of A intersection B complement. Alright, understood. Okay guys, now here are some very important properties of complements of set operation that you need to understand. First of all, what will be A union A complement? So, we are basically saying there is a universal set there is a set A. I want everything in set A and everything which is not there in set A. So if you combine both of them, you will get universal set, right? So A union A complement is universal set. Similarly, I want what is common between A and not A. Of course, nothing is common between A and not A. So 5. Next, I will come to this point later on. First, let's discuss it. Double complementation. Complement of complement will be set A itself, right? Because if you have a set, you find complement, then you are finding what is not there. Then complement of there means which is there. So basically set A. Similarly, null set complement, universal set. Universal set complement, null set. Okay. Now coming to the most important law that we have, DeMorgan's law. It states that A union B complement is basically A complement intersection B complement, or A intersection B complement is basically A complement union B complement. I am removing all this so that you can note down these laws. So DeMorgan's law basically says that A union B complement. Now what is A union B complement? Which is the blue region in this picture, this region. Why? Because first of all I am finding out A union B. So this is A union B, A union B. Complement of that means which is not there in A union B. Similarly, if I find out A complement is which is not there in A, not there in B. So this part is neither in A nor in B. Therefore, it is the DeMorgan's law proof that A union B complement is equal to A complement intersection B complement. And similarly, A intersection B complement will be A complement union B complement. So remember, intersection becomes union, union becomes intersection. Okay, when we are doing whole complement. Let's verify this with the help of an example also. Yeah, we are doing questions. Let the universal set be this. The two subsets given by A and B. Verify A union B complement is A complement intersection B complement. First of all, left hand side and we have right hand side. Left hand side we have A union B complement. What is A union B? Quickly tell me. What is A union B? A union B is 11, 12, 13, 7, 8. I want to complement this. Complement means something which is there in universal set but not there in A union B. So which is there? 9 is there in universal set. 10 is there in universal set. So 7, 8, 7, 8. 11, 12, 13, 11 and 12. Oh, 13 is also there. No, 13, 13 here. So we don't need that. So we are basically getting 9 and 10. Now on the right hand side I have A complement intersection B complement. Now what is A complement? Can you guys tell me? What is A complement? Something which is not there in set A. A complement is, it will not be empty. A complement is something which is not there in set A.